Good morning, everybody. Thank you for attending another e-learning session with us here at Peerless. Today we have Paul Long back from HoseMaster to talk about corrugated metal hose, the design, installation, and typical failure modes. So again, if you look around the room, you'll see a bunch of other people in your industries, OEMs, chemical, engineering, manufacturing, university, with a bunch of states represented, including Canada today. While we're on this page, I'd like to take a moment to shout out to Kodak, who's been in the news lately for quite a large contract they've just been awarded, and it's an exciting project, and they're our neighbors in Rochester, of course. So congratulations to you folks attending from Kodak. So here at Peerless, again, our customers have become, they rely on us for highly complex projects, keeping their plants running smoothly. And naturally, we're proud of the opportunity we play in every project that comes our way. We have three segments in our company. Our ProCore division focuses on our OEM customers, our custom engineered equipment, packagers, skid builders, and CapEx projects. Again, our process group deals with customers like Kodak, our chemical, pharmaceutical contractor, food and beverage, manufacturing. And then our high temp division that we manufacture high temp insulation and work with laboratory and scientific services. So again, Paul Long, many of you have been in the room here before with Paul Long of HoseMaster, and again, Dan Morgan, Greg Barrell, and me, our business development. So you also know, if you've been in attendance before with Paul, that he was the starting center for the Ohio State Buckeyes. And naturally, as the center, you have a very close relationship with your quarterback, who may be a household name in sports. It's Kirk Herbstreit. So again, before I turn it back to Dan Morgan, what you may not know about Dan is he also has a football card named after him. Only it is a different Dan Morgan. While Dan Morgan works hard to continuously improve Peerless, the other Dan Morgan is working hard to continuously improve the Buffalo Bills. And as a Bills fan, here's one who hopes he succeeds. So Dan, I'm going to turn it over to you.
Thanks. Yeah, honestly, it's been really helpful to keeping a low profile on the internet, because a Google search of Dan Morgan does not result in anything related to me whatsoever. So really helpful. But yeah, so for those of you that are joining us, for a second time or third or more, you know the drill, know how this works. But if this is your first time joining us, I'm just going to explain a few things, introduce the control panel a little bit, and tell you how it's going to work. But as I do that, what I'm going to do here is launch a quick poll. So you'll see a question show up on your screen right here. So what we're trying to do is just get a little bit more of an understanding of your level of experience with metal hose and sort of how it applies to your world and your environment. So we're hoping that you can maybe take a second and review these options, and just select the one which which best applies to you. That way, that'll help maybe Paul or us tailor the presentation a little bit more to suit the things that are important to you. So we'll leave that up for a couple more seconds. If you're having trouble clicking it, you may have to minimize out of full screen. We've seen that be a problem before, so if you're experiencing that at all, maybe give that a try. But while that's up, I'll also explain how the question section works. So as Paul is giving his presentation, if there's any point in time where you'd like some clarification, or maybe have an additional question about anything that's maybe related to you or your process, your situation, and like some interaction with Paul, please submit a question through the questions panel that you'll see in your control panel, and I will be keeping an eye on those, and I'll be finding appropriate moments to interject those questions into Paul's presentation and hopefully get you the answers you're looking for. So please don't hesitate. I know we obviously are open and welcome to as much interaction as needed. So perfect. Looks like we got a lot of votes here. About 80% of you guys have responded. And I think, there you go. Okay, so as you can see, it's a pretty diverse array, designing equipment with the hose, and simply interested about learning more have been the greatest responses. So thank you for for participating in that and giving us a better idea. And yeah, Paul, I think if you're ready, you can take it away.
Okay, thank you, Dan, and Kevin. I wanted to start out quickly. The last time Kevin showed a slide of my actual trading card back in college being sold out, and I joked about my wife and daughters buying all of them. I just wanted to confirm that fact that they did in fact buy all those. So
it's good to have fans.
So to kind of confirm that, since we're going full go here, I figured I'd bring up my helmet, kind of show that I actually did earn a couple of Buckeye stickers, if I can.
Very nice.
Look at it the way it's same way. So
none on the other side though?
No, one side. You know, we weren't that good that year, so you know,
it's good stuff.
You do what you can do. So thank you guys once again for allowing me to present on behalf of Peerless and Hosemaster. And hopefully everyone can see my screen right now. And today we're going to concentrate on corrugated metal. I'm sorry.
Sorry, real quick. We can actually still see the control panel. Maybe you can minimize that or kind of drag it off screen, possibly. I think if you maybe click the orange arrow.
Yeah, there we go.
That's good enough.
Good enough. So today we're going to concentrate on corrugated metal hose, proper application tips, typical failure modes, and that kind of separates into 4 basic sections. First is selecting a metal hose to begin with. I'm going to touch a little bit on how we fabricate that assembly, how Peerless fabricates it, because Peerless does weld metal hose in their shop. So whether you get it from Peerless out of Buffalo, New York, or they in fact, come to us and we fabricate that assembly because it may be something unique that they don't carry on their shelf. It's fabricated in the same manner, to the same specifications, so that the customer is always getting the similar assembly when they receive it in. And then we're going to talk about installation, and that kind of goes along with failure modes that we're going to touch on, and then discuss a little bit about what happens in the startup of a system. So hang on one second, let me try to. So at Hosemaster and with Peerless's help, we try to provide solutions to our customers. We have an engineering staff that's 10% of our workforce. We have over 500 employees. So we devote a great deal to engineering and providing solutions to customers' needs and requirements in the field for their applications. We manufacture 3 separate products at Hosemaster: corrugated metal hose, strip wound hose, and also expansion joints. But like I said, we're going to be concentrating on metal hose in this presentation. So we would love to always know how our product is being used in the field. On the left-hand side of the screen is a segment from a still mill. And as you can see, there is a number of hoses nested in and around and over one another. And that becomes pretty hectic. We like things in a kind of straight path from inlet to outlet, but sometimes in a piping system or in a facility, that's impossible to achieve. In the perfect world, it may be great, but for your specific facility, where piping might have been put in place years ago, and heavy equipment that can't be moved was put in place years ago, sometimes we just have to make the best out of a bad situation. On the right-hand side of that slide is a photo of a new plating mill that was never or has never been commissioned and been up and running. And when they went to put it together, they have all these brand new parts and found that the hoses that they have don't match up to the flanges that were sent in their different manifold systems. So here's an instance where maybe two people weren't on the same page, where everything was designed, plumbing, piping, pieces of equipment. The hose might have been an afterthought, or, hey, guess what? We need somehow to connect this. Let's get something flexible. Oh, it's a hot application. We need metal hose. And whomever never found out the proper length that the metal hose needed to be and how the routing was. So we want to make sure that we're trying to answer all these questions up front so we don't have a problem or an issue down the road. First off, we want to answer the question, do you even need to use a metal hose? So when would you do that? Obviously, temperature extremes, whether it be cryogenic service or whether it be steel mill applications where you may be seeing 1200 degrees continuous. We also want to know the chemical or the media that's going through that specific hose. We have different alloys of hose, so obviously we want to make sure that we're preventing corrosion anytime we can. Permeation, there's a chance that the medium may effuse through the wall of the hose. We want to make sure that that doesn't occur, especially if it is something that may be hazardous. Potential for catastrophic failure, that comes into play because all of our fittings are welded to the end of that assembly. Abrasion and overbending. Fire safety kind of plays with number one with temperature extremes. So if we're running maybe even something flammable through our hose, a lot of our hoses are used in gas stations across North America. Obviously, that's a flammable liquid. We want to make sure that that hose, if there, God forbid, is a fire in and around a dispenser or it's knocked down by a car or whatnot, that that hose doesn't immediately melt once it sees 400 degrees or above. Achieving full vacuum, number 7. Our metal hose will not collapse if you pull a full vacuum inside that assembly. And then number 8 is fitting configuration, the flexibility in which we can weld anything that's a metal alloy to the end of our hose. So it allows us great flexibility in coming up with an assembly that may work for a particularly tough application. Along with that first slide of why would you use a metal hose, after we've answered that question, we go into, okay, so now we know we need a metal hose. What kind of metal hose do we need? So there's some more questions that go along with that. Most of these are commonsensical. However, we still review them to just make sure that everything is understood with size, temperature. We'd like to know the application, the media that's going through it. Obviously, pressure is a big one that we need to know in order to select the correct hose with the correct amount of braids on the outside to contain that pressure, and fitting configurations so that when you get it, you're able to install it into your piping system, and dynamics. If there's any pressure fluctuations or anything else going on in that system that we should know about up front. We also would like to know if a certification of any kind is required with that assembly, because after the fact, we can't go back and just say, oh, guess what? We can just send you a letter saying that that hose is CGA approved or UL approved or certified to an ASME criteria. So we definitely need to know that information up front while we're designing and quoting that. So once we answer those stamped criteria, we get into selecting what hose style is going to work for that particular application. So we have several kinds. Anuflex is our standard, where it probably encompasses about 70% of the applications out there. We have hoses such as Masterflex that are more flexible in case a tighter bend radius is needed. We have pressure flex and pressure max, where elevated pressures are concerned. We have ChemKing, which is manufactured from an alloy called C276 or Hastelloy if corrosion is a concern, whether it be chlorine or other. We actually have an assembly named ChlorSafe, specifically designed and manufactured for chlorine transfer. So after we select the proper hose for that application, if we need to calculate the length that it needs to be from point A to point B, inlet to outlet, we have calculations that can aid in that. You can call Peerless and they can lead you through it. You can call Hosemaster, whichever we need to do in order to get you the correct length for your application, we can calculate that for you. But we also have these in all of our literature on metal hose. So it's pretty much of a formula, plugging in what those distances are, what the bend radius of the hose is, and then concluding with that final live length of hose needed to or required in order to make that movement, make that installation, whatever it may be. So if it's a traveling loop, if it's an angular deflection, if it's a lateral offset, we have formulas for any type of installation you may have. After we select that length and the proper length, we have to weld fittings onto the end of that. So those are all done by ASME Section 9 welders. This is what we call our Main Street in Cleveland, Ohio at Hosemaster. So we have 90 ASME Section welders to aid Peerless in their fabrication needs or requirements. On any given day at Hosemaster, we can put out 3,000 completed finished assemblies from start to finish into the shipping dock, ready for shipment. Fitting, these are common. However, just to review them a little bit, probably the most typical connection is just a male MPT threaded fitting on each end. However, we can literally weld any type of fitting required for that installation, whether it be Victolic, whether it be flanged, whether it be a typical hydraulic fitting like a JIC, sanitary flanges. So virtually anything that's out there in the fitting world, we can make sure and adapt to being welded onto our hose. The top industry standard attachment technique is probably done on 90% of all assemblies. So what we do is we weld the inner core of the hose, the braid collar into what we call a cap weld. And then we take the fitting and make a fitting attachment weld to it. Both are a TIG process. After we've welded the ends to it, each hose that is manufactured at Hosemaster and Peerless is tested. Typically air underwater. However, if a hydrostatic test needs to be completed on that assembly, we can do that. We can test with high pressure gas. If a requirement states that dye penetrant testing has to be done, we can achieve that on the welds from the fitting to the hose. And then, of course, if it's a very critical application where we're dealing with a gas, such as chlorine, others, we can also do what's called a mass spectrometer test on that hose. So after that hose has been tested, if there's any special accessories needed or required by that hose, we can apply them at that time, like a fire jacket. If workers are in and around a steam line, we want to protect those workers in case they may come into contact with that hose. We can put a fire jacket or some other cover on the outside of the hose. We can also add that strip wound product that we also manufacture typically for bulk conveying to the inside of the hose to smooth out any flow or velocity issues, or we can put it on the outside of the hose in order to make a guard from that. And if you can see me, and hopefully you can, Dan, can you see me?
Yes, we can. And if you'd like to make Paul a little bit bigger, there's a little slider on your screen that you can kind of click and drag. This is for, I guess, the participants, attendees, not necessarily for you, Paul, but you can, I guess, increase the size of Paul's webcam and decrease the presentation if you'd like to.
Yeah. And so I had a sample of a hose with a guard. We call this a bend restrictor. So we're only putting it on a small portion of that full assembly, but it aids. And if the assembly is being put into a tight bend right at the end fitting, the actual bend radius of this guard piece is larger than the hose underneath it. So it won't allow you to overbend the hose underneath it, possibly leading to a premature failure. So just wanted to show you that example of that, what that guard looks like on the outside of the hose. Every time I do that, it locks my screen up, so I apologize, guys. Bear with me. I will get
yeah, so next time you may just need to like click somewhere inside the presentation to advance it. You can give that a shot, I'm not sure, but possible suggestion.
So we've built an assembly to the proper specifications. We've answered all the questions that we could possibly answer up front. But what happens if the hose still fails once it's been installed, which does occur, right? We're all humans. We try to do the best what we can do day in and day out. However, there's something that we may encounter that we couldn't see, we didn't know about, or other. So how does a metal hose fail? The typical failure modes of a metal hose: corrosion, vibration, overbending, torsion, so twisting of the hose because we have welded end fittings to them. If we don't incorporate a live swivel of some kind, torsion could lead to failure, abrasion, overpressurization, and axial compression. So we're going to go through these one by one. In this case, we're going to start off with corrosion. Here, there's sulfuric acid at a 93% concentration that we found out after the fact that was going through a hose. And it started pitting through the corrugated hose portion before making its way all the way through. And then the end user saw that that hose was leaking, pulled it out of service, sent it back to us and said, hey, why is this hose leaking? What happened to it? And we were able to, through a failure analysis, which I'll throw that out there right now, is that a service that we provide to Peerless on behalf of our end users in order to hopefully find a conclusion that will then lead to an assembly that will work for years and years and years in that same service where one may have failed previously. There's also in the corrosion world something that's called knife line corrosion, and it's exactly how it sounds. It typically shows up as a straight line down the length of an assembly, typically close to where we seam weld the strip that we bring in. And before making it into a corrugated hose, we make it into a tube. So there's a seam weld in that hose, and we try to do the best we can when we're making that seam weld with purging that as best as possible. However, it is still a heat affected area. So typically media of the corrosive nature will try to find whatever weak point in that hose is possible. And sometimes when a hose is installed and that seam weld is at the bottom of that assembly, typically is where all that media wants to collect as well. Concentrations can grow in those areas, and a phenomenon by the name of knife line corrosion can occur. And we typically see it. It doesn't happen every single day. We typically see maybe some hoses come back like this, twice a year. So it is one of those ones that does come up, and immediately someone will say, I can't believe the corrosion happened that perfectly. And once again, it's typically at the bottom end of that assembly where it was installed and typically close to where that seam weld is. Stress corrosion cracking. There's another type of corrosion attack on a metal hose where we have a media that has somewhat of a corrosive nature in an application where we have large amounts of vibration and movement. So over time, that movement coupled with maybe some vibration opens up the grains of that structure of that stainless steel, allowing that somewhat corrosive media to kind of fill those voids in and around that granular structure. And eventually over time, it'll lead to a failure. So we know what that looks like just from being in business since 1982, analyzing hoses over the course of that time, and there's typical patterns to all these types of failure modes. Pitting corrosion, it's really just how it sounds. What you find is little holes that start to form either on the ID of the hose, if the corrosive is the media itself, or sometimes what we'll find is that a hose will be out in a facility and there'll be some type of media or liquid dropping on that hose somehow or spilling on that hose. And we find the corrosion or the pitting corrosion happening from the outside in. Typical, it's like a conical in shape. So it just doesn't melt, if you will, through the wall of that hose. It takes time, it works, and typically it's cone-like as it moves from the ID of that strip to the outside of it. Vibration fatigue is a failure mode that's somewhat hard to define because we need to look at a whole host of different appearances of that hose, from not only the braid wire seeing that fatigue happen, but also, as you can see in the lower middle photo, we actually see that the vibration was so excessive in that application that it started moving the braid wires over the OD of those corrugations, acting like a hacksaw, eventually working its way through the thickness of that steel. And then in the photo to the right bottom, you can see how that fatigue fracturing starts to occur and work its way through that strip width. It just doesn't happen overnight. It's a course of time. Sometimes on our failure analysis, our team will put down it's beach marking. So as the waves come up on sand and then recede, it leaves that mark. Almost the same thing when we're dealing with fatigue. That first movement doesn't go all the way through that strip, it just goes a little bit. But over time, if it's seeing multiple cycles, heavy vibration, it will eventually work its way through that whole thickness to create a failure. Braid wear, here's a pretty good photo of what that looks like when it's high vibration or the braid hasn't been applied to the outside of the hose properly. That's why we machine braid all of our hose to make sure that the fit of that braid is as tight as it possibly can be on that assembly to ensure the proper functioning of that completed assembly. If it's not, or if it's seeing high vibration, you can see this braid wear pattern on the outside of the hose once you analyze it. Vibration-induced fatigue fracturing. Here's a photo of our strip wound hose, but in this case, the vibration was so excessive that it literally started shaking this metal strip wound hose apart, and little flakes start to fall away from the strip. Overbending. So typically overbending will leave on the outside of the braid what's called a bulge, where the braid starts to kind of crunch up in and around the end fitting. It could be in the middle of the hose itself. However, once that braid pulls away from that corrugated inner core, it leaves it unsupported as far as its pressure rating. So now if you thought you had an assembly that was rated to 1200 PSI, that same assembly, if it didn't have a braid, would only be able to handle 70 PSI. So once that braid bulges away from that inner core, you're really left with that 70 PSI, not the 1200 PSI that you originally thought. So we want to make sure that those assemblies aren't overbent when they're installed in the system. Severe torsion, typically it's indicated by a Z-shaped fracture of the actual corrugated hose. It zigzags across those convolutions. It doesn't travel along with them circumferentially. And typically, if we have rigid fittings on the end of the hose, or for the sake of an example, let's use fixed flanges on each end of that hose. If the bolt hole alignment isn't exact, and we need to cheat one of those holes over to align it properly, that whole hose is under stress. It's just been put under stress because it's a rigid fitting, it can't move. And so once that hose is installed and it starts to see that media flow, or it starts to see vibration from a piece of equipment, it's locked in place so those convolutions can't do what we designed them to do. And so this is a typical failure mode from that torsion. Abrasion, it's as simple as it sounds. So if we have a hose in an application and it's butted up next to a piece of angle iron, a piece of cement, an obstruction of some kind, and it has to move in order to function properly, it's going to wear right at that point until, unfortunately, it fails. Abrasive media on the inside of the hose also can occur. So if we have a liquid that has a slurry of solids flowing through it as well, those solids can start to erode the inside of that corrugated hose and start creating an abrasion there that wears through the thickness of the strip that we built it from originally. Overpressurization. We take a hose that's rated for 1200 PSI and we put it in something that's well above that. What happens is that hose inside wants to stretch. That braid restrains it, but once it's taken past its working pressure, it may be over stressed and start to grow inside that braid because it can't be restrained anymore due to the pressure that it's seeing. So what happens is those corrugations start to elongate, flatten out, and that's what is depicted in this photo. Here's the beginning stages of an overpressurized hose, where you can see those corrugations starting to bulge, actually pushing the braid wires out. Here's just some photos of overpressurization where you can see corrugations, how we design them, and then after it's seeing too much pressure, actually those corrugations starting to grow wider and wider apart. Compression and squirm happens when you take, say, a 14-inch assembly and install it in a 12-inch space. That assembly is compressed. Unfortunately, that hose assembly will allow you to do that. However, what happens is the braid bulges outside or away from that inner core, leaving that inner core unsupported. Once pressurized, just like in the overpressurization slides, the hose starts to grow inside the braid and eventually will push its way outside of those braid wires and eventually fail. So definitely two things that a metal hose cannot do. it can't compress and you can't extend it because of those welded fittings. If it's 8 feet long and you try to extend it, you're going to start to stretch those braid wires, making them brittle, leading to a possible fatigue down the road. Water hammer, shocks, or surge pressures in a system can also be detrimental to a metal hose assembly. If they are occurring in a system, we can manage those. However, we need to know up front because there's a derating factor that we have to apply to the working pressure of a specific style of hose. So we can prevent this. However, we need to know that up front. If we don't know that up front and that assembly goes into service, it's already derated once it sees that water hammer effect. And what you see here is that happening, that water hammer comes through that hose, it centralizes on a portion of that hose and creates an overpressurization at a specific point in that assembly. Typically, it's at the beginning of the assembly where the pressure hits it immediately. Hoses that are installed in a facility, and if you are doing a PM on those hoses, just some things to look at, but due to abrasion or some other issue, sometimes those braid wires can become frayed or broken. You want to make note of that because every time one of those braid wires becomes broken, it's going to reduce that working pressure of that assembly in some manner. So we want to make sure that those are identified so they can be replaced in a timely manner. So here we see not only some broken braid wires, but some dented braid wires. And we have an operations manual that kind of goes into these failure modes, do's and don'ts, to make sure that if somebody is doing a PM, they know what to look for and identify it properly. And just some proper handling instructions for metal hose. Once again, we like to say that this is commonsensical. However, touching base on it never hurts either. But if we're dealing with a hose in a coil, you want to uncoil that hose like you're rolling out a tire. You just don't want to grab one end and just start walking off to where you need to couple it up to. If it's a short installation, we want to see if we can maybe add some 90-degree elbows in order to install that hose within its proper dynamic minimum bend radius instead of forcing it into a tight position, possibly not giving it enough hose to actually do anything for that installation. Here's another instance where by incorporating a rigid pipe elbow, we take the stress off of that hose, and now this hose assembly can last longer in service. You don't have to worry about that becoming overbent, the braid to becoming bagged away from the inner core. If a hose is in a looped application, we just want to make sure that no torsion is being applied to that, and sometimes torsion is hard to see. So we like to use the example of being able to cut the center line of the hose from inlet to outlet with a pane of glass. And as long as you can do that, you know that assembly's in the correct plane or in the same plane. On the right hand of the screen, you can see that those two inlet and outlet, they're a little bit apart, they're a little bit angled. So now that hose isn't in the same plane. So all of those convolutions, they're already stressed, almost locked into place, not being able to move and do what we designed them to do. So if we see some up and down movement, side to side movement, vibration, fatigue is going to happen faster in a hose that's installed in a torqued manner than one that isn't. Once again, incorporating a pipe fitting in order to alleviate stress. Here we want to make sure in a looped installation that we have the correct length to make that connection between inlet and outlet. And we didn't make one too short because we don't want to stress that hose by pulling it in any way. If we have a larger hose in a looped application, or even if it's for a lateral offset, if the media is a liquid and it's a larger diameter, there may be some significant weight in that assembly. So what we want to do is make sure that that hose is properly supported, whether it be a trough, whether it be a sling or a bun of some kind. We always want to make sure that that hose isn't falling one way or another because of the weight of the particular media going through it. We want to make sure that it's supported and then moves in the way that it can. Tightening fittings, once again, bolt hole or flange connections, we want to make sure that we're tightening those bolts as if you were changing a tire on a car by going across from one another, not one to the next around that flange. If we have a JIC swivel fitting or some other type of swivel fitting that incorporates 2 hex nuts on there, we want to make sure that we're holding one so it doesn't move while tightening. You're using the other one to tighten it. Spoke about how compression can lead to a premature failure, so we want to make sure that when we're installing a hose, we don't install it in a compressed state. If there's another way that we can route that hose in order to eliminate that compression, we'd like to do that first. Or I should say, if that is not a possibility and you're limited on space, we may want to look at an expansion joint to handle this type of movement rather than putting a hose back into this service. Here's just another example of a hose being compressed on the incorrect side on the right hand of the screen. If we can, we'd like to loop that hose, so now that hose is free to do what it's designed to do, move back and forth, up and down, and handle those cycles properly. Sometimes when we're seeing multiple movements in an application and one hose is installed and there's a repetitive failure over and over again, like you see on the right hand of the screen, what we can do sometimes is create what's called a dog-leg assembly. And in essence, it's 2 hoses that are welded or coupled with a common elbow. And so with 2 hose assemblies, now we can make movements in 2 different directions. So now we don't have to worry about compressing that hose. We don't have to worry about torquing that hose. Now we have 2 assemblies being able to make up for those movements, allowing for a longer life. And we always want to make sure when we're installing a hose, it's perpendicular to the movement. And that's what this slide is trying to point out. If it's in line with that movement, you're going to have 2 things occur. You're going to have compression, or if that movement's away from the inlet outlet, you're going to have extension. And once again, both of those are detrimental to a metal hose. And that's the end of the presentation.
All right. Thanks, Paul. I'm going to turn this screen back over to Kevin real quick, but just kind of remind everyone, we don't have any questions right now, but you know, we will be hanging around for another couple of minutes. So you know, feel free if you you know, if there's anything else that you know, we feel you didn't cover or have any questions on. We're here, and we, you know, we'll be happy to answer any questions. So chances are someone else is thinking the same thing you're thinking. So don't hesitate if there's anything you need. So, all right.
Thanks, Paul. Thanks, Dan. Hey, one thing I did want to point out is I believe on your control panels, you may see 2 PDFs that are attached to there. One is Hose Assembly Live Length Guide, and the other is Operations and Handling Manual. Those two publications do have a great deal of information that Paul covered today. So we welcome you to go ahead and just download them and hang on to them for yourself when you're either looking through your plant for areas where you might have a potential opportunity for improvement, or if you're building a piece of equipment and you want to head some problems off at the pass. You see that's where they are, correct, Dan?
Yep, correct. They're under it's labeled handouts, and you probably need to expand that pane by clicking the arrow, and then you can just click on the link and it'll take you to a download page. So, yep.
Great. So on that note, it's interesting that a metal hose assembly is one of the few items in your plant that really does scream from a mile away before you ever have a failure. You can usually see the signs of problems. So if you have any areas in your plant where you think you want another set of eyes on, we'd be happy to get the us involved and the experts at HoseMaster involved for sure. So thanks again, Paul. Thanks again for everyone attending. And I'd like to point out that next week we do have Rio Temp back for diaphragm seal assembly, proper selection, best practices, and really just the differences in diaphragm seals themselves, assemblies, the options, the what to look for. So that will be next Wednesday, August 5th. And again, all our past recordings can be found on our website, and we'd be happy to custom tailor any day training for any customer out there that would like to do so. So we're going to wrap it up. Thank you again, and as usual, you will see a survey at the conclusion. We do welcome your thoughts, your critique, your ideas for improvement, and any other topic you might want to see down the road. So with that, have a safe week. Thanks for attending, and we'll talk to you soon.